Welcome to EPG Pathshala. I am Aparna, working as scientist in Quality Control Laboratory, Professor Jayashankar, Telangana State Agricultural University, Hyderabad. In the subject food technology and in the topic principles of food processing, we are going to learn about the chapter that is retort processing of foods. Retort processing of foods has been a very latest technology which is being extensively used by many consumers because the food industries are giving different kinds of foods with the retort processing technology. To understand retort processing, we should understand about the shelf life of the foods. As you all know, shelf life of the foods is an integral part which is related to the packaging as well as the product conditions. The major driving forces for innovations in food packaging technology has increased due to its rise in the consumer demands. Retort technology systems use steam or superheated water to cook food in its own packaging, thereby extending the shelf life and ensuring the food safety. Manufacturers of the food products who face a challenge in making their packaging product attractive to the consumers should define and design packages with an innovative look. The revolution in packaging technology has boosted up the food suppliers' mind to be very creative in providing a convenient food to the consumer. In fact, most of the grocery shops or the supermarkets want the food that they buy from the manufacturers to be as convenient as possible, which requires very little cooking time. In fact, from the consumer point of the view, the less time they spend to prepare a meal, the better it is. As mentioned before, new advances in technology of packaging has begun to transform the marketing and goods of the food products. Retort pouch technology is definitely a new solution to meet the consumer's demand, which will help the consumers save their time as well as energy, apart from giving them convenience in preparation of their meals. Autoclaves, which are known as retorts in food industries, have been a major technological feature of the preserved foods for more than 100 years now. Indeed, the first documented use of heat to preserve foods in commercial application dates back to the Napoleonic Wars during the early 1800s, which has been a reliable and straightforward methodology ever since. By the time of Waterloo, British troops had canned rations, and these also assisted many of the 19th and early 20th century explorers to reach their destinations. It was the confectioner Nicholas Appert in 1804 who sealed glass jars with pitch and discovered a way of keeping the food such as mutton, chicken, vegetables, milk, etc. from spoilage. Then in 1810, Peter Durand was granted an English patent for the metal can, which with a few minor differences is still the most common container for preserving foods even today. But it was not until Louis Pasteur in 1854 who demonstrated the effect of microorganism spoilage on milk. And it was then we understood that why heat is such an effective and safe form of preservation. Over the years, we have seen introduction of new generation of materials such as pouches, plastic pots, trays, etc., which are allowing more convenience, better product quality through reduced processing time, reduction in cost for food manufacturers, and better surfaces on which to provide the increasing depth of information that the consumers and the marketers are demanding. Apart from retorts, which are the batch operations where the product is introduced in a crate or in a basket, there are also continuous systems such as hydrostatic, continuous rotary, and hydrolock systems. But these are universally used for metal cans and have not been widely used for successful and novel applications of food and retort processing. Today, in this retort processing, we will also learn about the types of retort processing. Let us see what are the different types of retort processings which are available. There are three basic retort processes. One is the steam, second one is the falling water, and full water immersion systems. There are also subdivisions within each of these categories which include the steam, air, steam spray, water spray, and half immersion systems. It is emphasized that all the processes except the simple steam will work on all of the current container formats. So there is not necessarily a wrong process for the novel applications, especially for retort processing. However, it is clear that some principles of transferring heat to the sealed containers do have advantages over others when specifying particular packaging media. This is particularly so when we are choosing between rigid, semi-rigid and flexible packaging formats. While the tin can is processed in all three heating mediums, plastic pouches, CPET, that is the crystalline polyethylene tetraphthalate trays, are used for ready meal preparations and productions which have different requirements. Now let us look at each of the retort processes. The first one is the steam process. Coming to the steam process, this is the oldest form of autoclave and is usually a top-loaded vertical pressure vessel with straightforward controls. Pressurized steam is admitted to the chamber, driving the air atmosphere out of top of the vessel in a vent phase lasting up to 10 minutes. This valve is then closed and the temperature is slowly raised by injecting steam, creating overpressure from the temperature increase. Thus, there is no independent control of temperature and pressure, and because the gaseous medium is not mixed or agitated, air must be eliminated during the vent phase to ensure that there are no cold spots or cold pockets where the temperature is significantly lower due to stratification. Since air and steam do not readily mix out with assistance also, cooling can be achieved by flooding the chamber. The technology used in this type of retort presents significant challenges for modern processors. The vent procedure is expensive because 36% of the steam which is required for the process is simply exhausted to the atmosphere. The pressure fluctuations mean that it is virtually impossible to process pouches, semi-rigid pots and trays without distortion of the packs or the risk of cold spots occurring if compressed air is used to artificially create overpressure. And the vertical orientation of the retort means that full automation of the basket loading is not achievable. Then we have the steam and air process. The steam and air process is very highly effective in the development of the entire steam process for retort processing. The differences from the steam retort are the horizontal vessels, and the quick opening doors will facilitate the loading as well as unloading of the baskets, forced steam circulation, and most importantly, independent control of temperature and pressure is also possible. The steam air process was patented by Lagarde Autoclaves in 1972. In this process, the steam is injected directly into the vessel and a reduced venting time can be achieved by use of a high velocity fan to recirculate and mix the steam with any residual air, eliminating the occurrence of any cold spots. This highly efficient process was specifically developed for flexible and semi-rigid containers, initially for preparation of military rations in aluminum foil packs, but has seen many applications on stand-up pouches and ready meals. It offers rapid heating to give the shortest process times to maximize the food quality. Cooling consists of two steps here. The first one is a pre-cooling step that cools the retort chamber, gradually replacing the pressurized steam environment with compressed air. Then you have the second step that showers the hot containers with cold water, which is recirculated through an energy recovering heat exchanger. You can see the process in the figure 1 as being displayed. Then you have the water process. After the steam air process, we have the water process. Here we have the steam and spray system. This is relatively a newcomer to the batch retort processes. In 1983, a scientist from Spain patented a process that combines steam and water in an atomized spray. The atomized environment gives a very good heat transfer on the rigid containers during the come up or heating phase, as the water transfers its heat very quickly. A fan is not utilized to mix the atmosphere here in this system. Atomizing nozzles, which are placed around the circumference of the retort, take water from the pump, recirculate the condensate and mix it with the steam directly injected into the chamber. You can see the figure 2 which is being displayed. While rapid heating can be achieved, the atomizing nozzles by their design tend to restrict the water during cooling, leading to longer processing times than the conventional cascading water, immersion or water spray types. To get around this restriction, other manufacturers of this type of retort have considered and implemented separate heating and cooling circuits so as to maximize the efficiency of the process. Then we have the raining or cascading water system. The raining or cascading water system uses superheated water under overpressure to achieve sterilization temperatures. Water is heated through a heat exchanger and then pumped through a distribution plate and showers under low pressure onto the containers. This methodology is widely used in processing of glass container, as the water can pass between the containers as it falls, transferring heat through the side walls of the container. The cascading water process was first introduced in France in 1975. The exchanger in the circuit allows the steam that is used to heat the processed water to be recovered as a condensate, and then it can be returned to the boiler for reheating. Care should be taken to reuse the condensate because the concentration of minerals and the resulting acidification of the steam could be a possible disadvantage when we reuse the water in this system. Coming to the next technology, that is the full water immersion retort technology, which is very widely used across the world. This is comprised of a processing vessel and a pressurized water reservoir. You can see the figure 4 which is being displayed. At the start of the process, hot water from the reservoir floods the lower chamber and then reheated to sterilization temperatures. After the cooking process, the water is returned to the reservoir ready for the next process. A small amount of water is always retained in the processing vessel and is then recirculated and cooled through an exchanger to be sprayed onto the products so as to cool the products. The use of pouches and trays have tended to work against this process, as flotation of the packs needs to be controlled, leading to an increased cost in the basket manufacturing as well as in reduced flexibility. We will now see the next processing technology, that is the half water immersion system. Now, half water immersion system, as you can understand from the name itself, is where the vessel is half filled with water and a part of it is rotated in the water and part of it is outside the water. This can have certain advantages when the rotation speeds are high and there is less turbulence which is created by the cages which are used in the retort processing technology. Now, among all the technologies and types of retort processing techniques which we have used, which one is the best retort process? This is very difficult and it is impossible to select a single process and conclude that this is the optimal solution for every container type. However, there are distinct advantages and disadvantages when selecting a process type. The steam air process has been widely utilized in processing semi-rigid and pouch containers and is currently the most popular method for processing pouches, especially in pet food sector where highest volume of stand-up pouches is manufactured. As steam is a three-dimensional heating medium, there is virtually no difference in the pouch come-up times, whatever the position of the pouch in the basket is. Rapid cycle times can be achieved as the application of energy is direct to the pack and the amount of free energy available is greater in steam environment than in the water-based process, and there is no loss of energy through indirect heat exchangers. This leads to significant utility savings and increased output compared with similar sized vessel which is using an alternative heating method. It must also be emphasized that recirculation fan is critical to effectiveness of the entire process, and various safeguards to ensure fan operations are usually incorporated by retort manufacturer itself for both rotation as well as for the load maintenance. In addition, many novel containers which have plastic laminates with gas barriers that are sensitive to water at high temperatures, so a steam process is less invasive at temperature than either cascading water or full water immersion, as the rate of condensation at the hottest part of the cycle is lowered. The steam spray process gives good distribution during the come-up, but the pressure on each nozzle is critical to obtaining the correct atomization. In addition, there are concerns with flat containers and also the so-called umbrella effect, where during the come-up and hold, flat packets such as trays and pouches are usually shielded from the atomized environment due to the packs above them, which will inhibit the flow of the steam or the heated spray. Even with side sprays, good penetration cannot always be guaranteed where the layers of trays or pouches are tightly packed. Apart from that, maintenance of nozzles to ensure that they remain free of scaling or any other particulates is very critical. This is somewhat very difficult, and without entering the retort and removing the nozzles, it is very impossible to see the nozzles whether they are blocked or whether they are proper. Falling or cascading water is highly effective at penetrating the tightly packaged baskets of rigid containers such as glass containers or cans or vertical medium of water, and the penetration between the containers trickling down from the top to bottom is much better in these types of retort processing. Good thermal distribution is achieved by high flow, but the reservations are similar to those with the steam or spray processes when pouches or flat pots or the trays are used. Here the umbrella effect has to be again considered. Many of the problems with the umbrella effect can be overcome by using rotating retorts, where due to the containers turning end over end, water can penetrate more easily. By design, the water spray process means that products can take longer time to heat than in the steam retort, as the water has to be heated prior to being sprayed onto the containers or heated during the spraying if the product is cold or if the heat is lost throughout the exchanger. The immersion process is very good one for delicate heating for products and containers as well. In heavy loads, the water immersion route does give some kinds of additional support to the weight of the containers, but this is often countered by slow processes time, which is inherent when heating with such a large body of the water. In addition, with poorer nature of the seal qualities on the semi-rigid and pouch containers and contaminated water being transferred from batch to batch, leakage is an issue with coloring of the white plastics or white packaging material. There could also be sticky residues on the packages as well as water migration through the seals that makes the application of full water immersion for low temperature pasteurization more complicated. So the packaging material has to be very carefully selected if we are using the full immersion system retort technology. To overcome all these issues, there are certain new packaging developments which have happened over the years. with the use of thinner gauge glass and metal containers to reduce the cost of packaging, and with the adoption of so many plastic containers, retorts also have been changed rapidly to accommodate to more accurate and shorter processes required, along with the new packaging materials which have been evolved over time. The level of control directly affects the failure rate of semi-rigid or flexible containers. Better temperature and overpressure control places less stress on the packaging material, ensuring the seals remain hermetic and reduce the level of wastages. This is particularly true with the CPET trays, where the fluctuations either can lead to blown up seals or deformed containers, which will be ultimately rejected by the retailers. The wider use of recyclable plastics in the food, dairy, beverage applications, they also require accurate processing, and also the screen printed containers have been better served by steam rather than by water-based processing. The stand-up or Doypack plastic pouches have emerged as one of the major alternative formats to glass and metal rigid containers. The most successful products have been pet foods and the carbohydrates such as rice and the pasta. Indeed, the recent data shows phenomenal growth in the sales of pre-cooked rice, pre-cooked pastas, etc., and the annualized rate of increase in the growth has been estimated to be beyond 25% per year. Stand-up pouches require careful processing at poor pressure control, because if this is not taken care of, failure can be possible with the stand-up pouches retort technology. As the heat penetration time to the core is so short, the process medium chosen needs to reflect this, and it should be able to supply large amounts of energy during the heating stage very rapidly with minimal thermal lag between the top as well as bottom of the basket. A difference in internal temperatures of each peak will lead to varying amount of overpressure requirement, which is impossible to resolve in one common environment. The accurate control of retort pressure is therefore very crucial to success. We have other new containers like the Tetra Recart, which also requires specific thermal processing solutions to avoid the damages. A paper-based container in a wet, hot environment is not usually a good combination. However, the laminate makeup does allow full sterilization, though care has to be taken not to damage the packs and to avoid too much water at high temperature coming in contact with the inks which are present on the top of the container. Damage to surface during filling can also result in leaking of ink running during the process. Most of the retort manufacturers have recognized that retort control is very crucial for new style containers, and much effort is being made to use the latest electronic hardware to ensure the accuracy. The ability to reduce the process times to optimum is a very driving force for the food and consequently for all the autoclave manufacturers. Apart from these new packaging technologies, there are some advances and advancements which have happened in the retort technology also. The retort manufacturers try to evolve their equipment continuously so that the retort available today is significantly different from the machines which were available 10 or 15 years ago, which will suit for the current manufacturing procedures and formats. The fact that the design life of a retort is usually anywhere between 25 to 30 years, it also steers the new requirements and new developments. Let us now discuss about some of the latest retort developments. The first one is the dual process. Now, coming to the dual process retort technology, most retort manufacturers are very happy to argue that their process design, whether it is steam based or water based, is optimum process for any type of container or product, but this can be quite easily disproved because it is totally relevant to the kind of packaging and kind of the food which is being retort packaged. We know in general terms that steam or air is good for plastics and pouch, water is good for rigid containers such as cans and glass. But surely the optimum is a mixture of both. Water immersion retort manufacturers have offered the ability to shower or immerse products for a number of years, but recently Lagrade autoclaves have pioneered the development and installation of dual process retorts that can use either steam or water processes at just a touch of the button. You can see the picture which is being displayed. The first installations have been traditional to the food canners with an eye to divert some of their products into more convenient or modern pack formats such as pouches or polypropylene based bowls. The dual process facility allows optimum processing times on rigid containers using water spray and rapid heating to achieve short processing times for the pouches. This gives the food manufacturer the ultimate retorting facility which is capable of flexible, efficient manufacturing of any container shape or type also. Then after the dual process, let us now go ahead for the next procedure, that is the sterile cooling. Often fresh water is introduced to top up the process water. An internal preheating system can be fitted to pre-sterilize the fresh water to ensure sterility in case of sensitive packaging materials or double safety on the infant food products or such kind of food products. These exchangers can also be used as indirect cooling systems for applications where water is not desired to be in contact with the container. Some vented food packs are especially sensitive as the vent is opened during cooking but needs to be closed by fall in temperature to ensure a hermetic seal. In traditional water cooling, there would be a risk of water passing through the vent before it is fully closed, with consequences of contamination of the food packets. Then we have the rotary retorts. The rotary retorts is again a different kind of retort processing technology. With requirement of shorter process times for better quality, the average speed of the basket rotation is increasing. Some products are now being rotated at speeds in excess of 15 rotations per minute to obtain even rehydration or effective starch breakdown used in sauce and soup preparations. These speeds tend to prohibit the use of water-based processes as they are subject to both centrifugal forces in case of falling water or cavitation and poor flow dynamics in case of full water immersion, where the rotating cage acts as a giant paddle. In both cases, even distribution requires the replacement of heat absorbed during the heating stage. If the water is unable to penetrate effectively to the center of the basket, the result will be poorer distribution. Coming to the next advancement is the basket sizes. With pouch products, the weight of the product in each basket has fallen. But because of the need to contain pouches within individual pockets to avoid damage in the rotary retorts, the overall basket weight has risen. This has placed additional stresses on mechanical components within the rotary retorts. The retort manufacturers have fairly common design for drive system of the internal cage inside the rotary retorts. You can see the figure 6 as displayed. Here, the cage shaft is powered by a rear-mounted external drive through a mechanical seal. As you can see, the front of the cage is mounted on two rollers, and traditionally these have been mounted inside the pressure vessel. A number of manufacturers have now mounted these varying parts externally in separate pressure housings, allowing easier maintenance. The heaviest loading, however, is for processing the glass jars. Line speeds continue to increase, and this requires bigger basket capacities. Pouch basket capacities continue to grow as food manufacturers try to gain greater efficiencies from each process. The latest retorts are now capable of processing around 3600 into 400 grams of pouches per single batch. After seeing the advancements in the retort processing technology, let us now see what are the future trends for this retort processing. Over the last 10 years, there has been a significant change in the profile of the retort users. Previously, an exclusive ambient food club's retort ownership has diversified to such an extent that many of today's major installations are on the chilled pasteurized products such as ready meals, ready to consume soups and vegetables, or in component processing for use in the production of other foods like rice, protein, vegetables, which are cooked prior to inclusion into the recipe dishes. Additionally, the food service sector has been looking at methods of extending life and making the distribution chain more efficient. Traditionally, the products have been delivered into restaurants or any kinds of hotels or markets which are needed to be ambient or frozen. But the increasing use of microwave ovens for food preparation has increased the usage of chilled prepared meals. Hospitals and schools are also searching for more healthier foods but with further cost saving. Then other things like reduction of salt is again a very major factor in the food processing industry, where the consumer is looking for very lower amount of salt in their foods. Then apart from that, 14 days of shelf life at retail outlets with no discernible reduction in the quality or flavor is another major advancement. Indeed, many products benefit from the double cook or in-pack cooking, leading to more rounded flavor. We have some cheaper cuts of meat such as shin beef, briskets, etc., which can be tenderized within the retort at low temperatures and cooling systems, which mean that the product can be discharged at chill temperatures across a high risk or low risk separation regime without additional handling. Because there is no downtime for cleaning between the processes, a retort is always flexible when it comes to handling the wide range of products which are found in the chilled food manufacturing. The increasing use of organic and spice ingredients, some with high initial microbial counts, have led to need to the decontamination by using pasteurization and sterilization techniques, and many food ingredient manufacturers are currently using retort products for materials like sauces, etc. in 5 to 10 kg pouches. Hot filling at 85 degrees centigrade on these types of products is not necessarily enough to eliminate yeast, molds and other spoilage organisms. Many governments, due to increasing prevalence of the degenerative disorders like obesity, cardiovascular diseases, etc., are asking for reduction in the salt in the processed food contents. Chilled products are now under intense scrutiny by officialdom as well as in the media, with all these concerns taken into the effort. Thermal processing requires no other preservatives. Low salt ready meals, etc. can now be achieved with longer shelf life and without any additional ingredients. In this way, the additional cost of thermal process can be obviated by a reduction in the cost of preservative as well as in the stabilizing ingredients. Another recent application has been that of pre-cooking of some kinds of meat like ham shanks, belly port joints, etc. The product, once cooked and cooled in a bag, is then dispatched to stores with hot food counters, then finishing off in the roasting cabinets. The process not only reduces the cooking time but also ensures the product's safety as well as quality without variability. Seafood processors also are able to use the retort processing technology for gentle controlled defrosting. The product is then prepared and finally cooked or pasteurized in the retort pouch prior to the dispatches. The two largest chilled seafood producers in Europe are now using retort technology to produce fish ready meals, taking shelf life from the market, limiting 4 days to an acceptable 17 days while still ensuring the quality, which is almost the same or better compared with the chilled foods. With the continuing consumer drive towards more convenience, vegetable growers also are now reaping additional margins by processing vegetables to a ready-to-eat state in pouches through retort technology. Chipped, boiled, mashed and even jacketed potatoes, part cooked, are all flooding the chilled foods market, and they require just a reheating in the microwave oven. The potatoes, roots and green leafy vegetables also are processed to offer maximum convenience. The main aim of the retort processing is to give good shelf life, minimal cooking time along with convenience, while retaining the structure, color and nutrient content of the foods. Retort processing has been extensively used since many years, and now it is being more extensively used for only the convenience of the customers. Coming to the conclusion of this entire topic, after learning about what retort processing is, types of retort processing, what are all the advancements in retort processing, we will now just see the summary and overview of the entire topic. So today's topic, we have learnt about what retort processing is, and we have also seen the types of retort processing. We have seen what are the advancements in the retort processing, and we have seen the various applications of retort processing in food industry. For further information, you can refer to any Principles of Food Processing book for further information and necessary study.